Solve using the quadratic formula. The equation 3t squared minus 4t is equal to negative 5. Well, in order to use the quadratic formula, we need to see this equation in standard form. So let's add 5 to both sides, writing this as 3t squared minus 4t plus 5 is equal to 0. Next, I'm going to write down the quadratic formula. T is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In our equation, let's identify a, b, and c. A is our coefficient of t squared. It is 3. B is the coefficient of our t term. It's negative 4. And c is this number by itself. It's positive 5. Now substitute those values into your quadratic formula to get the opposite of b, or the opposite of negative 4, plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a, which is 3, times c, which is 5, all over 2 times a, or 2 times 3. Now let's simplify. Up front, the opposite of negative 4 is 4, plus or minus. Underneath our radical, negative 4 quantity squared is 16, minus 4 times 3 is 12, times 5 is 60, so this becomes a minus 60, all over 6. Continuing to simplify, this value under the radical, this numerator becomes 4 plus or minus the square root of negative 44 all over 6. Now this is going to lead us into the complex number system because we've got the square root of a negative value. Let's write this numerator as 4 plus or minus. That 44 is 4 times 11. We've also got that negative 1 in there as well. The square root of 4 is 2. The square root of negative 1 is I. 11 stays underneath the radical. That's all over 6. Now each of our terms has a common factor of 2. We're going to cancel that 2 out. I'm going to factor the numerator as 2 times 2, that gives that 4, plus or minus I times the square root of 11, all over 6. And let's write that 6 as 2 times 3, so we can see our common factor of 2 that will cancel out. Lastly, 2 plus or minus I times the square root of 11, all over 3. Now, it's always wise to check both of these solutions in your original equation, and that check is going to verify that our solution set does include both of these. And I'm going to write these as one statement: 2 plus or minus I times the square root of 11 all over 3, or as